Okay, I
So
got
it
it.
is.
Let's just press the start button. Okay, all right. Okay, okay. So how do you get this? How do you get the thing to go back and forth faster? How do you get it to go for piston to move fast, 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 fast? Anyone has any idea? So if you condense it, it'll take a long time. No one has any idea how to get it to move fast, fast. So remember, we went over this in the I think many weeks back before we started doing all that volume of cone. So think about pressure cooker. What happens to the lid, that whistle of the pressure cooker? What happens to the whistle? Anyone? Does the whistle go up
Sir.
and does it stay up or does it come down? Yeah, who was speaking? Someone was speaking.
Yes, sir. Sir, when the steam
Mhm.
is released, we have to create a opening on the top so that after the piston move on top, the steam which comes in the cylinder releases out and go. And then when it comes down, again the steam should be the steam will come. Then again, this can increase the motion of piston in the cylinder.
Yeah, exactly. So if you look at the pressure cooker, as the water boils, the pressure increases. When the pressure becomes very high, high enough so that the pressure on the whistle is more than the weight of the whistle. So because of the pressure, the upward force on the whistle has to be more than the weight of the whistle. If the lower upward force from the steam becomes higher than that, then the whistle goes up. Okay, then the whistle goes up, and but when the whistle goes up, what happens? The steam starts going out. The steam starts going out. When steam starts going out, what happens? Why does the when will the whistle come down? When does the whistle come down? Why does it come down? Why does the whistle come down?
Sir, pressure is less and steam is let out.
Yeah, exactly. So um, when the steam escapes, then the pressure uh, then the pressure of the steam decreases. Because the pressure of the steam decreases, the force on the whistle decreases, and then when the force on the whistle decreases, the whistle comes down. Okay. Then what happens? Does the whistle come down and stay down, or does it? What happens after that?
Sir, again the steam will come and apply force. Then again the whistle will go on top and release all the steam, and then this happens continuously.
Exactly. So, so let me draw. Let me show the drawing. So that means the whistle keeps going up and down, up and down. Why? Because the pressure builds up, and then the thing goes up, and after some time, when the steam comes out, uh, then again the pressure drops, and then the whistle comes down. Now, how will you make it go fast, fast, up, down, up, down, up, down? Okay. So this is the pressure cooker, let's say. Okay, and then this is the fire. Okay, I'm drawing it very bad, but let me try to draw it a little bit better. Okay, so this is the pressure cooker. This is heating. Okay, then there is water. Okay, so let's say the water is still here. Okay, this is all water. Okay, this is water, and this rest of it here above the water is all steam. Okay, initially it's all air, and then the whistle is just uh, above this hole. So this is the whistle, let's say, okay, and the whistle also has a little bit of a thing that fits inside the hole. So okay, so initially this whistle sits on top of this, and this hole gets covered fully. Okay, and this is the water. Then water starts releasing steam, and because there's more and more steam here, the pressure increases. Because the pressure increases, the whistle goes up. Because the whistle goes up, the hole opens, and the hole opens, and the steam comes out. When the steam comes out, the amount of steam here decreases. Because the amount of steam here decreases, the upward force on the whistle also decreases, and so the whistle comes down. Now, how will you? So this is so now an actual pressure cooker. If you see, the whistle comes out every like maybe 1 minute, right? So it takes, once the steam goes out and it comes down, it takes another 1 minute for the for more water to boil and become and accumulate steam. So how will you make it go up and down very fast? Anyone has any idea? So you don't want to get 1 minute. Every 1 minute you don't want to go up, down, up, down. How do you make it very fast?
Sir, by decreasing the volume of the container.
Yeah. Actually, all you need to do is decrease the volume of this air part of the empty part of the container. So you want to fill it with more water and make this empty part, the air part of the container, very small. So if you do that part, then it will take very little time for the water to boil and fill up this thing once it has a base. So then it'll start going up more and more fast. Like this. So if you make it very tiny, then it will go up, down, up, down, up, down, up, down fast. Okay. So that is how you get up, down, piston motion, up, down, up, down. Now you want to convert this into actual train going forward or wheel rotating. How will you get a wheel rotating? Anyone has an idea? So did everyone understand how you get a piston-like motion, up and down motion by boiling water? Okay. Now, so the second part is from piston to you want forward motion. You want a wheel rotating. How will you get that? Anyone has any idea?
Sir, sir, by connecting a rod to the piston and the wheel.
Yeah, exactly. So I don't know if people have seen like sewing machine. There used to be this sewing machines, and you can pedal, like the person who's sewing, they pedal down on the thing, on the down on the with the feet, and with that you can get the thing to rotate. Very similar thing applies. So let's look at original James Watt's steam engine. So they have that, there's a figure in there. Yeah, but it's exactly that. But I'm trying to find out, there was okay, yeah. So I think this is basically doing the same thing. So let me switch to this one. So you do see this figure? So this is the piston, okay? And this thing is going up and down, up and down. Because this goes up and down, this will go down, up and down, up and down. And this is connected to this wheel here. So when it gets pushed down, then it will cause this circle to rotate anticlockwise. And you want to time this in a way so that it is getting pushed exactly when it is on the left side and pulled exactly when it's on the right side. So maybe I can draw a simpler picture in the slides. Okay. So a simpler thing would be, okay, so this is the piston. Okay, so let's say this piston is going up and down somehow it's going up and down, and then you connect a rod, and there's a wheel here. So this is the wheel. And then you connect a rod from here. Okay, so you can just connect a rod from here to here. Okay. And this wheel is fixed. So the wheel is fixed and this piston is moving up and down. So what will happen here? So when the if the piston goes down, then if the piston goes down, then the wheel will start rotating. It's going to pull this thing here. So it's going to start rotating and it's going to come here. So when this point comes here, that's exactly, you time it in such a way that at that time the piston starts going up. So if the piston starts going up, it will push the wheel. So if you make it so that the frequency of going up and down like this is exactly timed according to this wheel takes a half circle. So each time the wheel takes a full circle, the piston goes up and down. So if you time these two in the correct way, then you start getting circular motion. So that's how the wheel goes. Okay, is that clear? Is that clear to everyone? Does everyone understand the main idea behind the steam engine? How you can get motion from steam? Okay. Any other questions? Does anyone have any related questions that they are curious about in this topic? Feel free to ask any questions. Doesn't have to be exactly this steam engine works, but any related questions. Do people know how to get? I think we kind of briefly discussed this before. Do people know how? So do people know how car works? Who knows how car works? Does car have a piston that goes up and down, up down? What does car use? How does it get energy? How does the car get energy? Anyone? How does the car get energy? No one knows. What is how do you put energy inside a car?
So diesel.
Yeah, diesel, petrol, exactly. So which form of energy is that? What form of energy is that? It is chemical energy. Correct? And that chemical energy has to be converted into mechanical energy. Now, does someone have any idea how to convert this chemical energy into mechanical energy? Think about how would you, like, it doesn't have to be exactly how the car works now, but someone asked you to think, build some way in which you can take petrol and get this piston like motion. How will you do it? Think any idea? One thing you can do is, do you know what happens if you put a spark in petrol? What happens if you put spark in petrol? What will happen? Petrol is like fuel.
Sir, it will burn. Sir,
It'll burn. Yeah, it'll
the
keep burning.
burning causes motion.
The burning can be used to cause motion. The burning doesn't cause motion, but the burning can be used to cause motion. Right? But if you burn petrol, like let's say you fill in the car, like it takes 20 liters of petrol. So you fill your car with 20 liters of petrol, right? Or in a motorcycle, you'll put like maybe 4 liters of petrol, some number of liters of petrol. But if you burn that, what will happen? The whole gas tank of the car will explode, or the whole motorcycle will explode. Correct? So can you do that? You can't just burn the petrol as it. You have to do something special to get the motion. How will you have to take small amounts of it. You can't use all the light up that of whole petrol. You take a small amounts of petrol and light it up with a spark, and that'll cause some explosion. And then maybe you can use that explosion to get piston going up down, and then again take small amount of petrol, and then again piston, use that create a spark, and then get piston go up. Can someone think how you can do that? Does someone have any idea? How will you take small amounts of petrol to create small explosions? That small explosion can cause some piston to move. So if I take a piston like a small pressure cooker and I put a very small amount of petrol there and I light up a spark, what will happen? Do you know what is the main element in petrol? What is the main thing? What happens when you put fire on petrol? What chemical is there in the petrol, and what happens when you light it? Why does it explode, first of all? Petrol, what is the main elements in petrol?
Sir, paraffin.
Yeah, go ahead. No one knows the main elements in petrol? Petrol is a hydrocarbon. It's very much like charcoal, but it's liquid form. So charcoal is coal, right? It's carbon. How do you get energy out of carbon? Does anyone know how to get energy out of carbon? What is the chemical reaction that happens? The similar reaction happens when you burn petrol. What happens when wood is burning? Okay, when you burn wood, the log, most living things, including human body and plant body, everything, has what inside it? What is the thing that causes a wood to burn? What is the main thing inside it? What is the common element in all living things, most living things?
Carbon.
Carbon, yes. So carbon is the main fuel that is there in wood, is there in charcoal. And in fact, remember we discussed this, I think, that charcoal is nothing but, how do you get charcoal? How do you get coal in the mountains? When you dig inside and get coal? That coal comes from what?
Sir, when the wood burns in the absence of oxygen, it doesn't burn completely, but it burns slightly and becomes a good conductor of heat.
So the wood under a lot of pressure, actually the coal is same as wood. It's just that when it is buried inside and gets all the weight of the sand of all the earth, compresses it, then there is some transform that changes it into coal. So it's very old wood. Okay. And when you further keep pressing, you put a lot of pressure, then that coal becomes petrol. Okay. It doesn't become petrol, it becomes like the raw petrol. It becomes black petroleum, and then that by refining that you get actually the transparent petrol. Okay, so all these is nothing but ultimately it is the main element is carbon. And now how do you get energy out of carbon? What do you do to it? How does it keep burning? Who knows how energy comes out of carbon? What is the main chemical reaction? What is the main chemical reaction for carbon to burn? Carbon combines with something from the air. What does it combine with while burning?
Hydrogen.
Is there hydrogen? Is there much hydrogen in the air? Is there raw hydrogen in the air? Hydrogen atoms are there in the air? If you put a hydrogen in the air and if you put spark, what will happen? Can hydrogen remain in the air in gaseous form, in pure form? There is some place where there is a lot of hydrogen. It is not in pure form. It is not in pure element form, but it is in compound form. Where is most of the hydrogen? Is it in the air? Is there something that you put inside your body every day, which has hydrogen? What do you put inside your body which has hydrogen in compound form?
Water.
Yes, water has hydrogen. Why can't hydrogen be pure element in the air? Why can't it remain like that in the air? What will happen? If I take pure hydrogen in the air and I light a spark, what will happen? What else is there in the, what does water consist of? Water consists of which elements?
Hydrogen and oxygen.
Hydrogen and oxygen.
Yeah. So two atoms of hydrogen and one atom of oxygen becomes one molecule of water. Now, air has oxygen. If hydrogen was there in the air, and if you suddenly put a spark, what will happen? Will the hydrogen remain pure hydrogen, elemental hydrogen, or it will immediately react? It will immediately react with what? It will immediately react with the oxygen in the air. It will immediately react with the oxygen in the air. It will become water. So hydrogen cannot remain stable in hydrogen and oxygen together cannot be in the air. If it is there, then any heat, any sun, if too much sunlight happens or something happens, any fire happens, that whatever hydrogen, two atoms of hydrogen and one atom of oxygen will immediately react together to become a compound water. So either all the oxygen, this will go until either oxygen is finished or the hydrogen is finished. Now in the air, there is lots of oxygen. So because there is lots of oxygen, and even if you put a small amount of hydrogen, that small amount of hydrogen will get combined with that some small amount of oxygen and will become. So in any planet, it's very hard. On Earth, actually, we have lots of oxygen in the air, right? Now, maybe in some other planets, you might not have oxygen. You might have some other things, but it's very hard to have both hydrogen and oxygen because when they are both together, they react. They combine very quickly, easily. With small spark, with very small amount of initial ignition, they react and they become water. Okay, so that's why you cannot have both hydrogen and oxygen in a stable form in the air. Is that clear to everyone? Why you cannot have both hydrogen and oxygen in the air? Okay. Anyone has any doubts? Why you cannot have hydrogen along with oxygen in the air? So now we are talking about wood, right? Wood has carbon. What happens to the carbon when you so any chemical reaction, you need to initially put some spark, or initially you need to light up a little bit. Like even when you have gas cylinder in your home, or kerosene, anything, stove, anything like that, you initially have to light a small fire. When you have to light a small fire, then it starts burning on its own. It keeps burning, keeps burning, keeps burning. And what is happening during that when it keeps burning? What is the main reaction? What is happening to the carbon? Is the carbon combining with something in the air? Do you need air for that burning to continue? When you have a let's take about a candle, okay, candle or a diya, like in Diwali time you light diya, right, with oil. You put oil something and you light a lamp. It is using that oil. So oil is also basically carbon. So do you need air for the fire to continue, or you don't need air?
We need air, sir.
Yeah. If you Have you learned that if you cover up, you don't give it air. Like you take a lamp or a candle and you cover it with a jar, then the fire will go away. Have you learned this thing, or have you tried this experiment in school? Have you studied this in your textbook, or have you tried this in school? That if you take a lamp or a candle and you cover it with a jar, then over time the fire will go away, the flame will go away. Why does it go away? Why does it go away?
Absence of oxygen.
Exactly, yes. So that means the main thing required for the lamp to or the candle to keep burning, to keep having that flame, is the oxygen. So that means the carbon in the oil or kerosene or petrol or the log, that carbon must be needing the oxygen. What is it doing with oxygen? What is happening with the carbon and the oxygen? What reaction is taking place? No one knows what reaction takes place between carbon and oxygen. C plus O. What is the reaction? Oxygen molecule has two atoms of. What happens? What is the reaction you think? Do you get? Don't study these chemical reactions, these basic chemical reactions here in chemistry, in science. What happens when carbon and oxygen react? You get carbon dioxide, right? And carbon dioxide, when they react, heat comes out, energy comes out, and that's why you get the flame. That's why you get the heat. So when the log burns, it combines with oxygen and it releases energy because CO2 actually has less energy than separate carbon and oxygen. It's like the CO2 is like a tight, two molecules have stuck together, like these molecules have stuck together. The carbon atom and the two oxygen atoms have stuck together. So to convert from CO2 to separate carbon and oxygen, you need to break that bond. And that's why when you go from CO2 to break CO2 into carbon and oxygen, you need to put energy. But when you take carbon and oxygen and you combine them, you get energy. So in the forward direction, you get energy, and in the reverse direction, from when you take CO2 and you go in the opposite direction, you need energy. So when we breathe or when we burn charcoal, then we are actually getting energy out. Now, can you think of a reaction which is going backwards? There is some place in which you go opposite direction. You actually take the CO2 and you go backward and convert it to oxygen and separate carbon and oxygen. Who does that? You know something that does that? So this part. Where is this thing happening?
In the plant.
Exactly. Yes. In the plant is opposite things happening. Okay. Now in the plant, will it need energy to do this, or will it get energy by doing this? Second one. So let's call this as reaction 1 and call this reaction 2. Okay. So does the plant get an we when we do you know this is happening inside our body? How is this happening inside? When is this happening inside our body? So this is happening when we breathe. So this is happening in respiration. Okay. or burning of oil, coal, petrol, okay, or wood. This is happening in our respiration, let's say, okay? Human respiration or any animal respiration. And in plant, this is happening during the plant respiration. And how does it get? So this thing actually needs energy. How does the plant get energy to do this? Here in our respiration or when we burn, then we get energy, right? In the case of plants, it actually needs energy. Where does it get that energy from to do this? It needs to take a carbon dioxide molecule, break it up. And breaking needs energy to break something. Okay, it requires forcing those molecules, the atoms apart. So where does it get that energy from?
Sun.
Yeah, repeat once more. I couldn't hear that.
Sir, sunlight. It uses sunlight, solar power to break it.
Exactly. It uses photosynthesis. So it uses the sun's energy, the light energy. And that light energy, when it falls on the leaves, then somehow chemical reaction happens. And so it uses carbon dioxide from the air. And during photosynthesis, some chemical reaction happens. So that converts into carbon and then oxygen comes out in the air. So now in our respiration, it is opposite. We have carbon. Actually, what we have inside our body is not exactly carbon. It has carbohydrates. It is some compound which is carbon, hydrogen, oxygen all together combined. But the main thing is that the main part that is used is a carbon. Okay, so the carbohydrate still combines with the oxygen to produce some carbon dioxide. So you can just, for now, for simplicity, you can just think that there is carbon inside us in some carbohydrate form. It's actually in the fat form of fat, and that combines with oxygen to produce carbon dioxide. Now we were talking about car. Now car also does basically the same thing. Okay? It has petrol, which is again carbohydrate. It's carbon and hydrogen, hydrocarbon, but takes the carbon, combines it with oxygen. How does it combine? You put a small spark. You put a small spark, the carbon in the petrol will burn and it'll become, what will it become? When you burn petrol, what does it become? What does the petrol become? I said petrol was mostly carbon. What does it become?
Carbon dioxide.
Yes, exactly. Okay. So actually petrol is not just carbon, it is hydrocarbon. That means it has hydrogen and oxygen. It's some molecules from hydrogen and oxygen. So now when you combine it with oxygen, what will become? Will it become only carbon dioxide or will it become something else? Carbon dioxide and it will become something else. What is the something else that will come out? It has carbon and hydrogen. What other thing will come out when you combine oxygen with something which has carbon and hydrogen? The carbon combines with oxygen to become carbon dioxide. There's also hydrogen. Hydrogen combines with oxygen to become
Carbon hydroxide.
no. Actually, the hydrogen part combines. What happens if you just combine hydrogen with water? Sorry, hydrogen with oxygen. What happens? Just remember I said what happens with hydrogen. Okay. So if I take hydrogen, have you done these chemical reactions? These kind of things? Have you studied these things? Like chemical reactions? Or not yet? Do you know how to write these chemical reactions? What do you get when you combine hydrogen and oxygen? What is this?
Water.
Right? Water, yes. But actually, this oxygen, I've written O, that is one atom of oxygen. Is oxygen present as individual atoms in the air or it is present as molecules? So can I write it as one atom or what is one molecule of oxygen? How many atoms are there? Yeah. So I should actually, when you take oxygen from the air, it is O2. So I have to take 2 molecules of hydrogen, okay, and 1 molecule of oxygen from the air, and I will get 2 molecules of water. Okay? Now, does this reaction release energy, produce heat, or it takes heat? Do you think this thing produces energy, or does it consume energy? Produce energy, exactly. Okay. What about this one? Carbon plus oxygen. Does this produce energy or consume energy? Take in energy. Number one, does it produce energy or take in energy? If you burn wood, does it produce energy or release energy?
Release.
Produce.
Yeah. Yes, it releases energy, exactly. And in this one, does it produce energy or release energy? In the number two, when you're converting carbon dioxide, separating it into carbon and oxygen, does it produce or release? Sorry, does it consume or does it release? Number two.
Consume.
Yes, it has to consume. If the number one is producing and releasing energy, then the second one has to consume. Okay, by law of conservation of energy. So this one is this one releases energy. Okay. This one consumes energy. And in case of plants, it's from light. And this one releases energy. What if can you go the opposite direction? Can you take water and break and convert it into hydrogen and oxygen? Suppose I want to go into opposite direction. So I want to take, can I do that? Do you know if this is possible? Do you know if there is a way to get separate hydrogen and oxygen from water? Number 4 is possible. Can it be done? Does anyone know if can you get separate hydrogen gas and oxygen gas from water? No one knows this? How to get, is it possible to get separate hydrogen and oxygen from water? No one knows this? If it's possible to get hydrogen and oxygen from water? Okay, let me ask a random person. Okay, Bhumika Lonar. Do you know how to get a separate hydrogen and oxygen from water? Okay, Mahalakshmi Kori, do you know how to get separate hydrogen and oxygen from water?
No, sir.
No? No one has not studied this yet in science? Nobody has studied what happens when you pass electricity through water? Mahalakshmi, you have not studied electrolysis of water yet?
What, sir?
Electrolysis of water. Have you studied? When you pass electricity through water, how it splits into hydrogen and oxygen? You're not studied that yet?
No, sir. Sir, we are going to study in next chapter.
Okay, all right. Anyway, so let me show you this. This is a very so all you do is you can separate hydrogen. So first of all, tell me one thing. If there is a way to do this, if there is a way to get hydrogen and oxygen from water, will it consume energy or will it release energy? Will it need energy or will it give out energy?
Sir, need energy.
Yes, so it will consume energy. So I think in 1700 or something around 1800, someone found that if you give it electrical energy, if you pass electricity through water, then what happens is electrolysis. It's called as electrolysis, okay? And because of that, it splits into hydrogen and oxygen. So this is the how you do it. Okay, you just take water and you put a battery and you put some two metal rods inside, and you put a battery and pass current through it, and automatically the oxygen goes towards the positive end and the hydrogen goes to the negative end of the rod, negative end, negative side of the battery, and the hydrogen comes out from here and oxygen comes out from here. So you can actually use, and you can see videos on YouTube also on electrolysis. Maybe I can just show you here. But it's a very easy experiment to do also. If you have just some wire and some test tubes. But let's just see. It's a very short video. So let's just watch that video a little bit. Okay.
Now, I've been using Grammarly for years. Now, the great thing is Grammarly is free and easy to use. It not only
Okay. So what he has done is he has put water and he's connecting. This is like electricity generator. It's like a battery. Okay. Can you see my mouse?
Yes, sir.
Yes. I just connected this one end of the wire. He has put his two electrodes, like two metal bars, and it's connected one side here, and he has put two test tubes, two inverted test tubes, so that the gas can collect in the test tubes. And then he just turns on this machine. So it's like turning on the battery. So you turn on the battery, then electricity is passing through the water. Okay. See, after some time, the gas is collecting here. And you can see exactly this is double the volume of this one. This side has double the volume of this one. And in gases, the volume is very much dependent on the number of molecules. Okay. So this has double the number of molecules of this one. So can you tell which gas is collecting here and which gas is collecting here? So this has double the number of molecules as here. Okay. Hydrogen and oxygen are coming out on one side. One side hydrogen is coming out, one side oxygen is coming out. Can someone tell which side is hydrogen, which side is oxygen?
Sir, the left side is hydrogen and the right side is oxygen.
Okay. Why is the left side hydrogen and right side oxygen? In this test tube, you're saying this left test tube is getting hydrogen and the right test tube is getting oxygen? Are you
Sir,
saying this
because
one is
hydrogen is 1 and oxygen is 2.
So let's look at the equation, okay? So, okay, let's look at this equation. 2 molecules of water, when you break it, it gives you how many molecules of hydrogen, how many molecules of oxygen does it give? See, oxygen molecule has 2 oxygens. Hydrogen molecule has 2 hydrogens. Now, if you just take 1 molecule of water, you will get H2, 2 atoms of hydrogen and 1 atom of oxygen. So to get a molecule of oxygen, you need 2 molecules of water. And from 2 molecules of water, you will get 4 atoms of hydrogen, which will give you 2 molecules of hydrogen. So by breaking 2 molecules of water, you will get 2 molecules of hydrogen and 1 molecule of oxygen. Okay. So now going back to this figure, we can see that in this test tube, you're getting double the amount of molecules as you're getting in this test tube. So which is this and which is this gas and which is this gas? Right side gas is which one and left side gas is which one? When you take some amount of water and you break into hydrogen oxygen, will hydrogen molecules be double of oxygen molecules, or will oxygen molecules be double of hydrogen molecules? Sorry, repeat that. I couldn't hear that. Yeah, you can look at this. You can look at this reaction here. Which is double? Do you get double the amount of hydrogen molecules or double the amount of oxygen molecules? Anyone? Anyone wants to answer this? Pavitra? Okay, do you want to take a guess? Pavitra, is there? See, look at this reaction, okay? If I broke 2 molecules of water, I got 1 molecule of oxygen and 2 molecules of hydrogen. So which will be double of the other? Will hydrogen be double of oxygen or will oxygen be double of hydrogen? Yeah, someone was speaking actually, but it got. Can you repeat? Whoever just spoke. Yeah, if you're having problem with the voice thing, you can just type it in. You can just type it in the chat. That'll be easier. That way your connectivity issue will not be there. So whoever is speaking, do you want to just type whichever will be double? You can tell hydrogen will be double or oxygen will be double. Anyone else wants to guess? Yeah. Yeah, who was speaking just now? Someone was speaking something. Someone turned on their mic, but it couldn't hear. Prerna Hospeti, are you there? Are you there, Prerna? Okay, I can't. Nobody is responding. Let me ask someone else. Lakshmi Bargal, are you there? Sorry. Let's see, Lakshmi. I think she got disconnected. Okay, Madhumita Pujar, are you there? Yeah, Madhumita. Which will be double? Hydrogen will be double of oxygen or oxygen will be double of hydrogen?
So I think hydrogen will be double of the oxygen.
Yes. Why? Yeah, just explain why. It's actually, you're right. I mean, if you look at the reaction, it is right there. So can you look at the reaction and tell me why it will be double? Why hydrogen will be double of oxygen?
Because 2 molecules of hydrogen are present.
Exactly. Yes. So from 2 molecules of water, you get 2 molecules of hydrogen and 1 molecule of oxygen. So whatever the number of molecules of water are there, like if there are 1,000 molecules of water, okay, then you will get exactly 1,000 molecules of hydrogen and 500 molecules of water. Sorry, 500 molecules of oxygen. And that's why in this YouTube video, okay, you are seeing that this test tube is double the volume of this one. And in gas, somehow in gases, it magically turns out it's actually very surprising. Okay, why it is not easy to understand why that is the case. But somehow in gases, it turns out that the volume of any gas is directly proportional to the number of molecules, and it's not just for the same gas, but even for different gases. So if you take same number of molecules of hydrogen and look at the volume at the same pressure and same temperature, then the amount of space it takes is same as that of hydrogen at the same number of molecules. So it doesn't matter that one is hydrogen, one is oxygen. When you double the number of molecules, then the volume also doubles. So this test tube actually has double the number of molecules as this test tube. So this right side is which one? Which is the right side then? Is it hydrogen or is it oxygen? The right side has double the molecules. So right side is hydrogen or oxygen?
Answer?
Yeah, right side of the test tube. This right side is hydrogen or oxygen? This one. Right test tube. Repeat once more. Just tell once more. Couldn't hear. Tell once more. Whoever just said.
So hydrogen?
Exactly. Yes. So this is the bigger one, which is the hydrogen. It's a double one. And the reason why you get this hydrogen and oxygen is because it's a little not easy to understand. But somehow when you break the hydrogen and oxygen in water, actually the hydrogen is The hydrogen is positively charged, has some positive charge. For some reason, an electron, so the when you take the water molecule, okay, the oxygen somehow takes one electron from the hydrogen and it gets very close to the oxygen atom. So the hydrogen becomes positively charged and the oxygen becomes negatively charged. And that's why when you pass this current through it, then the hydrogen goes towards the hydrogen, because it's positively charged, it goes towards the negative part of the battery, the minus part of the battery. And then the oxygen goes towards the plus part of the battery. And that's why you start getting these two separation of these two things into the two electrodes, the two sides. So it's a little complicated to understand, but this was discovered in 1789 by some person. I'm just looking up in Wikipedia. Okay, so this is the Wikipedia page for it. You can read up more about it here. And you can see that in 1789, a scientist called Jan Rudolf Demain. Okay, so apparently he was from Dutch. He was from German Dutch. Okay, German Dutch chemist. He figured out that if you pass current like this to this, then it splits into hydrogen and oxygen. So this is how you get split water into hydrogen and oxygen. Now, this one will consume energy. Now we are talking about car. Car, actually, we want to use carbon. You want to go number one. Use carbon and oxygen to get energy. So let's go back to that question. How will you take petrol? If you take petrol, lots of petrol, like 5 liters of petrol, and you put a spark, the whole thing will explode. The whole thing will burn. All the carbon will burn immediately, almost within like few seconds or 1 minute it will burn. And it will all become carbon dioxide. So how do you use petrol in a careful way to get a piston moving up and down? What will you do? Can you think of a way in which you can take lots of petrol, but you can use small bits of it to get a piston moving? Anyone has any idea? So the main idea is that you take, what is the main idea? I said you take a small amount of petrol each time. Like let's say you take a small drop of petrol. What if you take a small drop of petrol, you put it inside a pressure cooker?
Only
Okay. Yeah, repeat that, sorry. Yeah, Pradeep, go ahead. Pradeep, you saying something?
sir, by releasing
Your voice is getting cut off. You can type it in. If your voice is getting cut off, you can also try typing it in. Or try speaking again. Maybe your voice will come back. You can try typing in your thing, whatever you're trying to say. Okay. Someone else wants to try? Does someone else want to try? Anyway, the main idea is this, okay? You take petrol, you take a very small part of it. Let's say you take a drop of petrol and you put it in a pressure cooker. Okay, you need air also. You need air and you need petrol. You cannot have just petrol. You need petrol and you need oxygen. So you need air. Petrol, one drop of petrol, or even tiny, even not even one drop, even smaller than that. And you put it in a pressure cooker, and then you put a spark. When you put a spark, that petrol and oxygen combines, and you get lots of carbon dioxide. So that's the explosion, okay? You get lots of oxygen, carbon dioxide, and heat. And because of the carbon dioxide becomes big in volume. So because of the heat, it becomes big. Lots of carbon dioxide. And because of that, the pressure vessel will go up. And then release the carbon dioxide and it go down. Again, somehow you put in one more drop of petrol and air. And again, you burn it and then you get that thing. So in a car, actually, this is all done automatically. What you do is there's petrol in the petrol tank. And then there is, from that petrol tank, you take it and there is a place where you mix it with air. You mix it with air and you make the petrol into small droplets, very tiny droplets. It's called the carburetor of the car. If you look up the car, read up about car on the Wikipedia, you'll see that. Something called the carburetor, where you mix up the air and petrol and you take the petrol into small drops. and then you put that into the engine of the car. Engine of the car is like a cylinder, it's like a pressure cooker, and you release that mixture of air and petrol. Small parts of it, you release that, and you time it in a way. You make the time it in a way, say that exactly every every fixed number of time, every few fractions of a second, a spark will come. So some amount of this air and petrol mixture will go into that piston, into that cylinder, and exactly at that time the spark will come. Because spark comes, the piston expands, and because the piston expands, that rotation of the wheel happens. Okay, and when by the time the wheel comes to the other side, the piston, the carbon dioxide air escapes, the piston comes down, and then again some amount of air fuel goes in. Again, I write that at daytime the part spark. So the spark is again done by using some battery. So exactly at the right frequency, every once in that fraction of a second, the spark also comes out. So that's the main idea behind how the car works. Okay. Does anyone have any questions about this? So we saw how the steam engine works. Okay, by burning coal and by producing heat and then by boiling water. And we also discussed roughly how the car works. The car works from petrol by burning the petrol in the pistons. Very similar to the pressure cooker. Any questions about this? Okay, if not, then let's close for today. Okay, thank you. Bye bye.